Algebra half. We're on page 39. Our lesson today is called Divisibility. Okay, not too challenging, certainly not a very long lesson. The number 2 can divide into, let's say, the number 30 evenly, meaning we get 15 with no remainder. Thus, we say that 2 is a factor of 30, and also that 30 is divisible by 2. 2 is a factor of 30. 30 is divisible by 2. Other factors of 30 are 3, 5, 6, even 10, 15, and believe it or not, 30, right? Factors of 30 numbers will always include themselves. And we can divide by 1 too. 1 in themselves. So all of these will go evenly into 30, and then you can just think to yourself, well, what does 3 yield? It yields 10. What is 5 into 30? 6. 6 into 30? 5. 10, and we go on and we go on. Those are the numbers that result. Those are the quotients when you divide by these numbers. The capability of a whole number to be divided by another whole number without a remainder is called divisibility, and it's often helpful to know if a whole number is divisible by things like 2, 3, and 5. Okay? A whole number is divisible by 2 if its last digit is 0, 2, 4, 6, or 8. What's an example of a number divisible by 2? Let's do 200, right? Divide that by 2, you get 100. It ends in 0. And if we ended it in 4 or 6 or 8, or we use a different number that ends in one of those, they're all divisible by 2. You can see a series of other things that are true here for different divisibility situations. Divisible by 3 would be add up the digits, and are those divisible by 3? It's just a little bit quicker to think that way. For example, 33. What if I didn't know, is 33 divisible by 3? Take each individual digit and add 3 plus 3. Is that answer divisible by 3? And yes, that would yield 2. Now that's not the answer to the original. This is not 33 divided by 3 is 2, but now we know it is divisible by 3, and sometimes that's all you want, to know it's divisible. What about 5? What's it say for the rules of divisibility for 5? Last digit in the number is 0 or 5. These are things you kind of learned already in kindergarten. You started to see the pattern that if a number ended in one of these, no matter what the first digit, 60, 65, right? You know that those are numbers you can divide by 5. And why don't we talk about 10, as long as we talked powers of 10 recently. The last digit needs to be 0, even if it's a lot of zeros before that 0. It still ends in 0 and is divisible by that. So is a million divisible by 0? Or 10, I should say? Absolutely. All numbers are divisible by 1 in itself, and then you can follow the divisibility rules, and right now particularly for 2, 3, and 5 to help you. Example 10.1, top of page 40, asks, which of the following numbers are divisible by 3? Let's pick a new color, pink. Is 99 divisible by 3? Yes, and why? We could check it very quickly by adding the digits. 9 plus 9 is 18, and we know, since that's a smaller number, 18 divided by 3 is 6, comes out even without a remainder, which means the original number, 99, is divisible by 3. We don't even have to say the answer. It just asks us yes or no. So in your book, you would just write yes. Yeah. What about 1239? Divisible by 3? Add up the digits. 1 plus 2 plus 3 plus 9 comes out to 15, and 15 is divisible by 3. without remainder. 1,561. Add those together in your head. What is the answer? Uh-oh, 13. You can even try it on your calculator if you don't believe me. That is not divisible by 3. So A and B were, but not C. What about divisible by 2? Yes, ends in 4. Divisible by 2? Yes, ends in 2. Divisible by 2? Ends in 0. Just follow divisibility rules. And your own little chart is on the bottom of page 39. Okay, why don't you try... there's really only one practice problem. So A, B, and C for all those numbers. What takes time is writing out the numbers. But it's good practice because you're going to have to do it in the assignment. So be neat. Write it on your lined paper answers for the practice. Confirm you get them right. Return them to your math notebook for the future. Thanks for listening.